This is a short problem, just two mistakes you have to avoid. Normal stress sigma n over a, and shear stress tau v over a. A being the cross-sectional area, n is the normal force, and v the shear force. And if we want to set up this problem with a cool little problem statement for your TA Serenity, we'll say that she won a lifetime supply, 800 pounds of snacks, which is way too many to fit in the kitchen, so we have to put them out back on our deck, which means that there's going to be 200 pounds through this 2x4 holding up the deck. And actually, 2x4s are not good for holding up decks, but we'll just go with it. But with wood, it usually breaks along the grain. So instead of being interested in normal stress, just in the length, the direction of the wood, we're actually interested in normal and shear along the grain, which in this case is a 20-degree angle. So we're going to set up our free body diagram via method of sections where I've cut the wood instead of perpendicular, cut along the 20-degree angle. Normal force is still perpendicular to the surface. Shear force is still parallel to the surface. Now, the first mistake is to just use X and Y in the regular, normal, horizontal, and vertical directions. Set up your sum of forces in the X direction equals 0, sum of forces in the Y direction equals 0. You've got two equations and two unknowns. You can solve this. But there's an easier way. If instead you rotate your coordinate system so that the X direction is along the ramp and Y perpendicular to the ramp, now when you write your sum of forces in the X and Y directions, you'll only have one unknown in each equation, and your algebra is going to be a million times easier. In this case, I've got shear force V as negative 187 pounds and normal force N negative 68.4 pounds, which at first looks like I'm just horrible at guessing directions because I guessed both of these angles wrong. But in actuality, you should almost always put N in that perpendicular direction because a negative value for N will then mean you're in compression instead of tension. All right, just one more thing and then we're done. We just need area. So mistake number 2 is going to be to use 2 inches by 4 inches, the cross-sectional area of the wood beam. Every other time that would be the correct answer because that's normally how you do it. But since we're interested in breaking along the slope, there's actually a lot more area along the angled surface. We don't just need the height of 4 inches, we actually need the hypotenuse of this triangle. So I draw out this triangle, sine of 20 degrees, I get L is 11.7, which gives me area 23.4, and now I just plug in all the numbers. And again, the negative sign for average normal stress means that this is in compression. The negative sign for shear, not actually that important.